Okay, so today's question is called count primes. So count prime is number 204 on Leetcode. So 204 called count prime. The difficulty of this question is easy. Okay, so the question is given count the number of prime numbers less than a non-negative number n. Count the number of prime numbers less than a non-negative number n. So the example that I gave is 10. And we want to write Mr. Fu and return 4. And the explanation is from 0 to 10 there are 2, 3, 5, and 7 that are like prime numbers. Ooh, is this easy? How do you determine if a number is a prime number or not? So this is a question that reminds me of the math class that I took in elementary schools. So what is a prime number? What is a prime number? So a prime number, an example of prime number is 2, 3, 5, 7. 2, 3, 5, 7. What is the next prime number? I think it's 11. But the definition of a prime number is a number that can be divided by itself or 1. So it's like, for example, 2 can only be divided by 2 or 1. 3 can be divided by 3 or 1. 5 can be divided by 5 or 1. Oh, this is tricky. 7 or 1. So how would you determine if a number is a prime number or not? I mean, I have some idea on how to do it, but it might not be the most efficient. And according to Leetcode, they didn't specify what is the range of input. Alright, I think the strategy is we would want to write a function called define as prime. But it's going to be slow. My algorithm right now is so slow because like I'm thinking of M. So I'm thinking of so I'm thinking of like writing this function called s prime, and s prime is supposed to return a boolean, either like true or false. There are some hints that I can look at. Should I look at some hints? I mean, the idea is like, for example, if we have like m, I want to divide it from 1 to m. If I divide m by value from 1 to m. If there is any value that is divisible by 1 to m, it means that m is not a prime number. So in order to do that, I would just like do for loop. So for I in range from 2, I don't want to count 1 because every number is divisible by 1. So and then if nope, no more return true. So this would be a basic algorithms that I want to do. And then for the actual function, actual solution would be so I also want to test n. So it would be, so if s prime, I want to do out plus equal one, and then return out. But this solution is going to be very inefficient, and the reason that is inefficient is it's like n square. So if you look at here, so for example, if the value was like 10, we would iterate through 0, no, 2, 3, blah 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 to 10, right? So we basically like iterate like n times, so that would be on. But for each iteration, we also need to do we need to pass this value to a function called s prime. So in s prime, we also like iterated from 2 to 2, but for this case, it would be from 2 to 10. I mean, we can save some time by passing this s prime by a list, and this list containing all like primes value that we have found. So that would be it is going to save us some time. So the operation is going to be on time m. So in the case that we did not pass a list that containing the current prime number that we have found, it would be O n squared. However, if we write our algorithms to contain a list that contain all the previous or contain the found prime value, we would reduce it to O n times m, where m is like the number of primes value from 0 to n. Yeah, I can like modify this code a little bit, so I can call another array, and then right here we call array is equal to empty. So if it is so we want to return out, and right here if we figure out if a number is prime, we want to pop it into array, and right here when we call this prime, we want to also include array. Here we want to have 2. And also we might want to have like some cases like over here. Just do 1 out right now. And we want to check like on top right here if n is less than 2, we want to return 1, because if it was 1 itself is a prime number, is it? No, 1 is not a prime number according to Leetcode, because when we put 10 into the function, we only got 4, and there wasn't any 1 right here, so I guess we just return 0. In the case that n is equal to 2, we want to return 1, because this loop won't get run at all. Is it one got ran or one get ran? It will not get. It won't got ran in here. Alright, does it make sense? So in the case of phi, let's do the iteration. So we want to iterate 3, 4, 5. So first we pass 3. So we pass 3 to this loop, and then oh, now we need to change this. So instead of this, we want to do for I in array if m mod I is equal to 0. So if it's divisible by other prime numbers, we want to return false, else return true. Alright, let's look. Right, so in the case that the value of m is equal to 3, we would go through this array. So our array containing 2 right now, so 2. So if you take 3 mod 2, we would get 1. So this is not true. So and then we return true. And in the case of 4, it's so if we pass 4, now we iterate through 2. Since it's divisible by 2, it's going to return false, so it's not going to be appended. It's not going to update the output value either. So I think this algorithm should work, but let me code it and see if I pass all of the test cases. Alright, I think this is like a good time to stop. Thank you for watching, and I hope that I will keep like doing like one problem each day and continue and keep working on this kind of mini projects that I want to commit to. Alright, thanks, bye.